Hey guys, this is Roya, and today I'll be talking about projectile motion. In projectile motion, an object follows a trajectory that moves through space as a function of time. So if you were to follow my paintbrush here, you'd see that the end of my paintbrush is moving through space as a function of time in both the x and the y direction. Now, here we have Abby, and she's 3 years old, and her grandfather is trying to teach her how to play baseball. On her first ever throw, Abby's ball goes from her hand up into the air and lands on the ground. Now, if we were to draw a force diagram of the ball, we would see that the only force acting upon the ball once it has left her hand is the force of gravity, or mg. Now, you might think that there's a force moving the ball upward and to the right, but in fact that's just the velocity that's causing it to move that way until acceleration pulls it down. So as we can see, acceleration acts only in the y direction. So if we were to write an equation for the change in y, or the y function, we would see that y equals -1/2 gt squared plus initial velocity times time squared plus initial y. Now, if we want to find the initial velocity in the y direction, we have to go back to our trigonometry. If this is the initial velocity, and this is the angle theta from a horizontal line, then we see that this is the initial velocity in the x direction, and this is the initial velocity in the y direction. Now you can go back to the trigonometry videos to see how to find the components of the velocity, but basically you're going to be using the y velocity here. That's a y. Okay, so going back, we can now look at the x direction. Now there's no acceleration in the x direction, which means that x will not have this segment, and this is movement or motion due to acceleration. So x just equals initial velocity in the x direction times time plus initial x. As we can see here, if our x starts from here and goes over to grandpa over here, then initial x is 0. However, initial y is from the ground to her hand, so initial y is actually a considerable height. And so once you have the components of the velocity, you can now find the motions in each direction of the trajectory. So here's something to help you visualize the motions in the x and y directions. If this were the ball as it were leaving Abby's hand, if we were to look at only the change in y, we'd see that the ball starts going up, and then it reaches velocity of 0, and it goes down and down and down at a faster rate because of gravity. If we were to look at the ball only in the x direction, we would see that it's constantly going at the same rate until it hits the ground. That's how you can think about the changes in x and y.